Spring Boot, why I chose it as the backend for my platform. Hi everyone, in this video, I'd like to explain why I deliberately chose Spring Boot as the backend framework for my platform. Today, there are many excellent frameworks available: Node.js, ASP.NET Core, Quarkus, Micronaut, and Go are all outstanding technologies and are widely used in modern software development. Yet, I decided to build my platform with Spring Boot, not because it's the newest framework, not because it's the latest trend, but because, for the requirements of my platform, it provides the best overall solution. This isn't a tutorial on how Spring Boot works, and I'm not going to show you how to build a REST controller. Instead, I want to explain why I made this architectural decision, what advantages Spring Boot offers, and what role it plays in my platform today. At this point, Spring Boot is much more than just a REST API. It handles authentication through Keycloak, integrates with Contentful, generates dynamic XML sitemaps, provides REST services for the Angular frontend, manages security, improves performance through caching, executes background tasks, and serves as the foundation of my entire server architecture. More importantly, it gives me a platform that can continue to grow. Whether it's AI services, microservices, asynchronous communication, or completely new features, the architecture is already designed to support future expansion. So let's take a closer look at why Spring Boot turned out to be the right choice for this project. Choosing the right backend. At the very beginning of this project, I had one simple question: which framework should become the heart of my platform? From day one, I knew I wasn't building a traditional website. My goal was to create a platform that wouldn't just work today, but could continue to grow and evolve for many years to come. Even during the planning phase, I already knew that the platform would eventually include a wide range of features: a headless CMS powered by Contentful, authentication through Keycloak, REST APIs for the front-end, Docker for reproducible deployments, Jenkins for a fully automated CI/CD pipeline, caching for better performance, scheduled background jobs, monitoring, search engine optimization, and eventually even AI-powered services. That made one thing very clear: I needed much more than a simple HTTP server. I needed a backend framework that could reliably support all of these requirements from the start, and continue to scale as the platform evolves. I wasn't looking for a solution that would solve only today's problems. I wanted a solid architectural foundation that would allow me to add new features, integrate additional services, and keep the platform maintainable as it grows. For me, choosing the backend wasn't just about selecting a technology. It was about making the right architectural decision for the future of the entire platform. What I expected from my backend needed to be much more than a server that simply responds to HTTP requests. It had to become the central foundation of the entire platform, the place where all business logic comes together in a clean, reliable, and maintainable way. From the very beginning, I knew it would need to provide REST APIs for the Angular frontend, encapsulate all business logic, integrate Contentful as a headless CMS, and work seamlessly with Keycloak for authentication and authorization. Beyond that, it needed to process JWT tokens, generate XML sitemaps for search engines, and execute scheduled background jobs automatically. Communication between different parts of the system was another important consideration. The backend had to support both traditional synchronous REST communication and asynchronous processing for tasks such as notifications, background jobs, and future event-driven messaging. Database access was equally important. I wanted a solution that would make working with PostgreSQL simple, secure, and easy to maintain. Spring Data provides exactly that, while still allowing direct SQL whenever more control or performance is required. Containerization was another key requirement. The entire backend had to run consistently inside Docker and integrate seamlessly into an automated Jenkins CI/CD pipeline. That includes reproducible builds, automated testing, Docker image creation, and reliable deployments. Performance and operational reliability were also essential. From the start, the architecture needed support for intelligent caching, monitoring, health checks, and clean configuration through profiles and environment variables. Just as important was maintainability. I wanted a clear layered architecture, excellent testability, and a codebase that could continue to evolve without becoming increasingly complex. Even in the early planning stages, I knew the platform would continue to grow. Future features would include AI services, intelligent agents, WebSocket-based real-time communication, file uploads, email services, batch processing, advanced search capabilities, and eventually dedicated microservices. That meant I wasn't looking for a collection of individual libraries that I'd have to assemble and maintain myself. I was looking for a complete backend platform, one that already provides the building blocks for modern enterprise applications while remaining flexible enough to support whatever comes next. For me, that's exactly what Spring Boot delivers. A modern digital platform comes to life. At its core is a headless content management system that manages articles, images, and metadata. Content flows seamlessly into a powerful backend, where all application logic is processed. As the platform evolves, additional capabilities are integrated one by one. User authentication, REST APIs, business logic, automatic XML sitemap generation, security, monitoring, scheduled background jobs, intelligent caching, and protected member areas. Every component works together as part of a unified architecture, creating a secure, scalable, and future-ready platform. The backend serves as the central hub, connecting the content management system with the frontend, the database, and external services, ensuring that every process runs reliably, efficiently, and in perfect synchronization. Today, every component is responsible for exactly what it does best. The backend handles all of the platform's core responsibilities. It provides REST APIs, executes the complete business logic, generates XML sitemaps automatically, manages JWT-based security, and integrates Keycloak for authentication and authorization. It also connects Contentful to the platform, runs scheduled and background tasks, improves performance through intelligent caching, monitors the health of the system, and generates automated failed-to-ban reports to help detect suspicious activity. Meanwhile, the front end focuses exclusively on delivering a fast, responsive, and user-friendly experience. The content management system has a single responsibility: managing content. This clear separation of responsibilities results in a clean, maintainable, and highly scalable architecture, where every component is designed to do one job, and do it exceptionally well. By keeping each part of the system focused on its own responsibilities, the platform becomes easier to develop, easier to test, and much easier to extend as new features are added over time. Why Spring Boot? Choosing Spring Boot wasn't about following a trend. It was the result of a careful architectural decision. For my platform, I needed a framework that wouldn't just meet today's requirements, but could also grow, evolve, and remain maintainable for many years to come. One of Spring Boot's biggest advantages is its incredibly rich ecosystem. No matter what feature you need, chances are there's already a mature, well-tested solution that integrates seamlessly into the platform. Another major benefit is the outstanding documentation and one of the largest developer communities in the world. That means long-term stability, proven best practices, and reliable solutions for almost every challenge you might encounter. Security was another key factor. With Spring Security, the framework already provides a solid foundation for authentication and authorization. Combined with Keycloak, it becomes possible to build a modern identity and access management solution with very little custom security code. REST APIs are another area where Spring Boot truly excels. REST controllers, JSON serialization, validation, exception handling, and API development are all first-class citizens within the framework. Dependency injection was equally important to me. It keeps components loosely coupled, easier to replace, and significantly easier to test, resulting in a cleaner and more maintainable architecture. Speaking of testing, that was one of my highest priorities. Spring Boot integrates perfectly with unit testing, integration testing, test containers, mock MVC, and fully automated C/CD pipelines, making it easy to verify the quality of every change before deployment. Containerization was another essential requirement. Spring Boot applications work exceptionally well with Docker, allowing the same application to run consistently across development, testing, and production environments. But above all, one factor outweighed everything else: long-term maintainability. A clean architecture, well-established conventions, outstanding tooling, and widespread industry adoption make Spring Boot a framework that I can confidently build upon for years to come. That's why Spring Boot became much more than just a technology choice. It became the foundation of my entire platform. A modern software platform is constantly evolving. Built on a stable core architecture, it gradually expands with new capabilities such as artificial intelligence, intelligent search, notification services, analytics and reporting, image and document processing, and powerful background services. Each new module integrates seamlessly into the existing platform, extending its functionality without requiring fundamental architectural changes. The platform grows naturally into an intelligent, interconnected ecosystem where every component works together efficiently. Data flows continuously between services, illustrating scalability, extensibility, and long-term reliability. The architecture reflects the design of a modern enterprise platform, built not only for today's requirements, but ready to embrace future technologies and continue evolving for many years to come. A modern software platform is constantly evolving. Built on a stable core architecture, it gradually expands with new capabilities such as artificial intelligence, intelligent search, notification services, analytics and reporting, image and document processing, and powerful background services. Each new module integrates seamlessly into the existing platform, extending its functionality without requiring fundamental architectural changes. The platform grows naturally into an intelligent, interconnected ecosystem where every component works together efficiently. Data flows continuously between services, illustrating scalability, extensibility, and long-term reliability. The architecture reflects the design of a modern enterprise platform, built not only for today's requirements, but ready to embrace future technologies and continue evolving for many years to come. The platform was designed from the very beginning with future expansion in mind. Today, its components communicate primarily through synchronous REST APIs. This approach is simple, reliable, and perfectly suited to the current size and complexity of the application. As the platform continues to grow, additional independent services can be introduced whenever they are needed. These could include an AI service for intelligent automation, a notification service for email, push, or in-app messaging, a search service for high-performance full-text search, and an analytics service for collecting metrics and generating insights. Each of these services can be developed, deployed, and scaled independently without requiring fundamental changes to the existing platform. This allows the architecture to evolve step by step alongside new requirements while remaining flexible, maintainable, and ready for the future. That's exactly the kind of scalability I wanted to build into the platform from day one. Conclusion. For me, choosing Spring Boot was about much more than selecting a framework. It was an architectural decision. I wanted a foundation that not only meets today's requirements, but also provides a solid platform for everything I plan to build in the years ahead. Today, Spring Boot already powers the core business logic of my platform. It connects Contentful, Keycloak, and the Angular frontend, exposes REST APIs, handles security, manages background processing, and provides a clean separation of responsibilities across the entire application. At the same time, the architecture is designed to evolve. Whether it's microservices, asynchronous communication, AI-powered services, or entirely new capabilities, the platform is ready to grow without requiring a fundamental redesign. That combination of stability, flexibility, and long-term maintainability is exactly why I chose Spring Boot. I wasn't interested in building something that would only solve today's problems. I wanted to build a platform that can continue to grow and adapt 5 or even 10 years from now. And that's exactly why Spring Boot was the right choice for this project. Thank you so much for watching all the way to the end. I hope this video showed that choosing a framework is about much more than picking a technology. It's an architectural decision that shapes how a platform will evolve, how easy it will be to maintain, and how well it can scale in the future. If you're interested in topics like software architecture, Spring Boot, Angular, Contentful, C/CD with Jenkins, Docker, testing, or modern enterprise application development, be sure to check out my other videos. I'd also love to hear your opinion. Which backend framework would you choose for a project like this, and why? Leave your thoughts in the comments below. I'm always interested in hearing different perspectives and discussing software architecture with fellow developers. If you enjoyed this video, don't forget to like it and subscribe to the channel so you won't miss future videos about modern software engineering, architecture, and real-world development projects. Thanks again for watching, and I'll see you in the next video.